Before we dive down into regression analysis, we need to discuss a few preliminary things. Okay, we'll begin with some basic counting principles. These are called n factorial, that's how you read this, and n permutate k, and n choose k. There are different ways to express these things, but these are some of the expressions that are common. For n choose k, sometimes people instead will write like this. It looks like a fraction in parentheses, but there's no line here. Read as n choose k. So n factorial, n permutate k, and n choose k. So n factorial is defined. That's what this symbol means, defined to be. Sometimes people write this like a heavy-duty equals sign. N factorial is defined to be the product of the first strictly positive integers. Okay, so for example, 5 factorial equals 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is 120, okay? And it turns out n factorial is exactly the same as the number of ways to arrange n items in order from left to right. To see that, for example, suppose I have 3 different items and I want to put them in order left to right. How many ways can I choose the first one to put here? There are 3 ways, right? I could put star there, or circle, or triangle. Once this space is filled, there are only 2 options left for this space. I could either, if star goes here, then I've only got these 2 to choose from to go here. 3 ways. Once that's taken care of, 2 ways, 1 way. So 3 factorial is just 6. Also, we define 0 factorial to be 1. The number of ways to choose and arrange k items from n items is expressed like this: npk, which we read as n permutate k, and it's defined to be n factorial over n minus k quantity factorial. So suppose now you have 4 items, okay? Oh, heck, let's do 5. You have 5 items, okay? But you only want to choose 3 of those items to take with you or whatever, and then you also need to put them in order. You're concerned about the arrangement. Well, there are 5 different ways to choose the first one, right? And then once that's done, there are only 4 remaining ways to choose the next one, and then 3 remaining ways to choose the next. So it should be the case that 5 permutate 3 is 5 times 4 times 3, which is 60. Okay. Sure enough, if we follow the formula, it's going to be 5 factorial over 5 minus 3 quantity factorial. So that's 5 times 4 times 3 times 2 times 1, all over, let's see, 5 minus 3 is 2, so this is 2 times 1. That stuff cancels with that, and we get what we got before, 5 times 4 times 3. See how that works? 60. Okay. Note also that n factorial is just a special case of this permutate business. N factorial is just n permutate n. That is, if there are n items and I want to know how many ways can I choose n items from n items and then arrange those in a row, that's n factorial. That's just npn. So really, this is just a special case of that. Finally, we have n choose k. N choose k is a lot like n permutate k, except when we talk about choosing, we don't care about the actual arrangements of the items. In this case, we're just wanting to know how many ways, that is, how many different subsets of size k are there in n items. That's, again, like I mentioned before, it's sometimes written this way. Usually, I think probably most of the time, it's written this way, but it's defined to be, look, in fact, it's exactly this stuff, right? You see that right there, but then divided by another factor of k factorial. And this makes sense because suppose you have, again, 5 items, and now you're interested in knowing how many different ways you can just say, choose 3 of these items. You don't care about the order. Well, let's solve this first. What did this give us? That was 5 times 4 times 3, but it should be off. This should be too much. This is too much to be 5. Choose 3. Okay, what's it off by? Well, it's off by a factor of the number of ways to arrange these 3 things in order, which is 3 factorial. So that's why you're dividing by, that's, the 3 factorial. So that's going to be, what, 5 factorial over 3 factorial times 5 minus 3 quantity factorial, right? And see, watch what happens. What is the top there? It's 5 times 4 times 3 times 2 times 1. All that's over 3 times 2 times, 3 times 2 times 1. And then times, this is 2 factorial, so that's times 2 times 1. So this stuff cancels with this, and you get 20 up here, divided by 2 is 10. Okay, well, let's do an example. I think most people know what records are and what record players are and what CDs are, compact discs. We don't use those things all the time nowadays, but substitute anything you like. Books, coffee mugs, whatever. Suppose you have, say, 20 CDs, 20 compact discs. How many ways can you arrange those 20 compact discs on a shelf? Well, the answer is 20 factorial, which is going to be 20, my goodness, times 19 times 18 times and on and on and on times 2 times 1, right? Well, thank goodness I can use my calculator for that. So I could just do 20 times 19 times 18 times 17 times 16. Goodness, this still takes a while, doesn't it? Okay, 2.43 something times 10 to the 18th. That's a humongous number. So you can see these calculations get very tedious as the number of items increases. Thank goodness we have a special function in our calculator. Most software programs do these days, things like R and Excel. Just hit the math key there, arrow over to the prob menu. I think that probably stands for probability. Okay, we're not computing probabilities yet, but these things are often needed to do them. Okay, factorial is number 4. Whoops, I don't want to do that. Let's do 20 factorial. There we go. Option 4. There we go. Same thing. Now, assume that you're going to choose 5 of these CDs to take with you on this trip. All right, you're not going to take all 20 of these things. You're just going to choose 5 to take with you, or 5 shirts, or 5 books out of the 20 books you have, whatever it is. How many different ways can you choose 5 from 20? That's 20. Choose 5. The bigger number always goes on the left, right? Left, right, left, right. Or if you write it this way, the bigger number goes on top, right? So that's 20 factorial over 5 factorial times 20 minus 5 factorial. You're going to have a lot of canceling going on in here, right? This is 15 factorial. Will cancel with a bunch of the factors up here, and you'll just be left with 20 times 19 times 18 times 17 times 16 up here. So you could do all that in your calculator and just do, 20 times 19 times 18 times 17 times 16, and then divide by 5 factorial, right? Like so. 15,504. 15,504 ways to choose 5 from 20. Let's check that with the calculator. I could just enter, let's see, bigger number goes first, right? 20, and then math. Choose option 3 now. Option 3, NCR. 20, choose 5. Okay, there we go. Yeah, and they're the same. Okay, so the calculator and other software like R and Excel will do these things for you straight away. These numbers get really big really fast, so we don't want to have to do this stuff by hand. Last question. Usually when people read books, they read them in order, right? Sometimes they'll read 1 or 2 at the same time. Certainly people don't usually listen to 2 CDs at the same time. Okay, so how many ways can you choose 5 things from 20 and put them in order, left to right, or read them in order, or experience these things in order? Well, that's just going to be, that should be the same as the number of ways to just choose those things, but it's off by a factor of the number of ways that you can arrange those things. 5 factorial, right? So I'm just going to do that. Yep. And in fact, if I do 20 math PRB, go here to option number 2 now, NPR, N permutate R, and permutate 5 like so. You get the same thing. 1,860,480.